Hi there, we are doing the notes for 7-4, division properties of exponents. So first off, the learning target, all right, I can use division properties of exponents to simplify and evaluate expressions. Go ahead, fill in the word division. Take a minute, do the 4 warm-up problems applying negative exponent rules, power rules, and see how we do. All right, so hopefully we have the following answers. All right, so you can take a look at what is highlighted. Those are the final answers that I am looking for. If you have any questions, then come see me about these warm-up problems. All right, let's get started. So let's use some repeated multiplication, okay, to solve the following. And then what do we notice? So we have 2 to the 7th divided by 2 to the 4th. I'm going to make a big fraction bar, and I'm going to use repeated multiplication. You all know that this 7 tells me how many times 2 is being multiplied. Always double check 1, 2, 3, 4, 5, 6, 7, and then divided by 2 to the 4th, which means I have 4 2s. So that's using expanded form of repeated multiplication. Now, just to review, if I have a fraction that looks like this, 2 divided by 2, you know that that equals 1. So I can go ahead over and I can look, and I'll change colors here so you can see. This 2 divided by that 2 equals 1. This 2 divided by that 2 equals 1, or cancels, cancels, cancels. So if I have to rewrite what's left, I can rewrite it as 2 to the 3rd. And notice they're my numerator. There's nothing left in my denominator. And 2 to the 3rd is my final answer, right? And I could evaluate that if I wanted to. But before we do, I want you to look at what I'm going to highlight. I want you to look at the 7, the 4, and the 3. How can we go from 7 and 4 to 3? So if you say, well, I know that 7 minus 4 equals 3, you're right? So we can subtract the exponents. All right, so let's go ahead and actually learn the quotient rule. When I divide like bases, again, like bases, they have to be the same. My 2's were the same. Change back to pink. I subtract my exponents, and I want you to write in top minus bottom. So please fill that in, top minus bottom. That's very important. So the numerator's exponent, which in our example problem is 7. Our denominator's exponent, which was 4. So 7 minus 4 gets you 3. So it's super important. So go ahead and make sure that's filled in. When I divide like bases, I subtract my exponents top minus bottom. And that's called the quotient rule. When we talk about quotients, right, the word quotient is the answer to a division problem. A fraction is some sort of division problem. So I really have in my example, x to the 9th divided by x to the 3rd. I can use my quotient rule. Like bases, so I can subtract my exponents. So x to the 9 minus 3 equals x to the 6th. That's my final answer. If I were to use repeated multiplication or expanded form, I can expand x to the 9th divided by x to the 3rd. I can double check my answer if I have one of those moments during a test that I totally go blank, but I know what exponents mean. I can do that. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 on the denominator, and then I can cancel, cancel, cancel. And I am left with x to the 6th. So I've just proven my quotient rule. Let's go ahead and look at some examples. I have like bases, so I can do a to the 8 minus 3, and I should get a to the 5th. Again, if you wanted to expand the numerator, expand the denominator, cancel what is like, you can, but you should end up with a to the 5th. Number 2, so I have like bases. I also have negative exponents, but I'm going to show you that I can still use the quotient rule. I can say x to the negative 3 minus negative 5. Don't worry that that is a negative in the denominator. I know my 2 pencil mark trick, when I subtract a negative, I'm really adding. So x to the negative 3 plus 5 is x squared. That should be my final answer. Well, let's think, what if we forget? Let's go ahead and rewrite the problem, and let's apply the negative exponent rule. The negative exponent rule says that the base that the negative exponent is applied to moves opposite, when in this case, x to the negative third should go downstairs and be written as x to the third. X to the negative fifth, right? Fighting downstairs, move upstairs, x to the fifth. And I can expand that if I would like to. I could say 1, 2, 3, 4, 5, and 1, 2, 3. And I can say cancel, cancel, cancel. Oh, I have the same exact answer, x squared in the numerator. So a couple different ways that you can solve these. All right, that was number 2. Let's look at number 3. Now I have 2 different like bases, right? I have b to the 5th and b to the 3rd. I can write that as b to the 5 minus 3 if I apply that quotient rule, times c to the 9 minus 2. And if you subtract those, you should get b squared times c to the 7th. There's your final answer. Again, you could expand and cancel the like bases. All right, and let's say number 4. So I'm going to have to apply another rule here. So everything has exponents here. And then I'm going to put in those invisible ones. And I'm going to apply the power rule. Okay? I'll rewrite my numerator. A to the 4th, b to the 3rd, c to the negative 5th. And I know that a to the 1 times 3 should be a to the 3rd. B to the 1 times 3 should be b to the 3rd. And c to the 1 times 3 should be c to the 3rd. All right, so now I have my like bases right on top of one another. So I can say a to the 4 minus 3 times b to the 3 minus 3 times c to the negative 5 minus 3. And I can continue on. I now have a to the 1st, b to the 0, times c to the negative 8. And so now I'm almost done, okay? So I'm almost done. So if I have, all right, I got to, first off, b to the 0 I know is 1. So I have really a to the 1st left over c to the negative 8. So this can go downstairs. All right, so I have a over c to the 8th as my final answer. That negative exponent goes downstairs and becomes positive. All right, so that's your quotient rule, right? When you divide like bases, you subtract the exponents top minus bottom. Let's go ahead up to the page and let's fill out our graphic organizer for quotient rule. And we are going to be adding another one underneath, but let's talk about quotient rule here. I have x to the a over x to the b. Like bases, remember I do the top minus my bottom for my exponents. So I should have x to the a minus b. And over here on our example, please cross out the one that's written there and write in 10x to the 3rd over x squared. All right, and so let's talk about this. Like basis, well, I have x to the 3rd and x squared. So I should have 10 to the x cubed minus, or x to the third minus second, which really is just 10x. Okay? All right, so now let's go back to page 9, I think. 10, top of page 10. And let's talk about quotient to a power rule. So let's look here. Let's use repeated multiplication, solve the following problem. All right, well, first off, I'm going to look here, and I am going to write 2/3 3 times, because that's what this exponent tells me to do. All right, and if I were to look here and use exponents, what would my numerator be? I have 2 times 2 times 2. Well, that can be written as 2 cubed. Then I have in my denominator 3 times 3 times 3. That can be written as 3 cubed. So if I take a look at my original problem, I'm going to put in those invisible exponents of 1. And I can highlight here, I'm going to have 3, 1, and then I have that 3 and 1, and I somehow end up with 2 to the third times 3 to the third. Looking at my exponents I've highlighted, hopefully you can think of, well, 3 times 1 gets me 3, and 3 times 1 gets me 3. So I can use the idea of the power rule, right? Power to power rule, think distributing. Now this is called quotient to a power rule because I have a division problem. So quotient to a power rule says when a quotient or fraction, because a fraction really is a division problem, is raised to an exponent, the numerator and denominator are each raised to that power individually. Okay, so think distribute. And yes, to both the top and the bottom, both the numerator and the denominator. All right, let's look at this example. I always put in my invisible exponents of 1. If there's another exponent, you don't put 1 in. But now, my quotient to a power rule says I can do x to the 1 times 3 over y to the 1 times 3, or 3 times 1. But I should end up with x cubed over y cubed. And that would be my final answer. Again, you think distribute. Okay? Let's look at some examples. I'm going to always go in there and I'm going to put my imaginary 1s. Now notice my y already has a 3, so I'll leave it there. And I'm going to think distribute. So I should have x to the 1 times 2. I'm sorry, 3 to the 1 times 2 times x to the 1 times 2 over y to the 3 times 2. I can go ahead and say, well, that's 3 squared times x squared over y to the 6th. And then if there is something I can evaluate, like if I could plug it in a calculator and get a value, I do that. 3 squared is 9. So 9x squared over y to the 6th. Final answer. All right, so quotient to a power rule. Let's look here at number 6. I'm going to put in those imaginary or invisible exponents of 1. They're not imaginary, they're there, just not written. And so I should have, let's say, 2 to the 1 times negative 3 over 5 to the 1 times negative 3. Okay, so I should have 2 to the negative third over 5 to the negative third. Okay, but wait, I got some, I have negative exponents. I got to apply that negative exponent rule. So remember, if my negative exponent is in the numerator, it goes downstairs and becomes positive. And then my negative exponent in the denominator goes upstairs and becomes positive. And remember, only the base goes with it. So now all of a sudden I have 5 cubed over 2 cubed, and that should be 125 over 8. And that's it, I can't reduce it. All right, and so must one. We look at this, it looks pretty intimidating. All right, but we take it base by base. Put in any missing exponents. There should be 4 to the first and 3 to the first. And take it base by base. I'll work with the numerator first. So I should have 4, 2, the 1 times 2 gets me 2. So 4 squared times a to the 4th, because I'm multiplying 2 by 2, times b to the 6th, because I'm multiplying 3 by 2. Denominator now. So I should have 3 squared times a to the negative 6th times b to the 8th. So now I have it where I can apply some more rules. So I can evaluate 4 squared is 16 over 3 squared is 9. And then let's look at my like bases. I can have times a to the 4 minus negative 6. Make sure you do that 2 pencil mark trick. Times b to the 6 minus 8. I continue. I still have 16 over 9, but I have it times a to the 10th. Right, 4 plus 6, and then times b to the negative 2. So I have one more rule to apply, that negative exponent rule. But take a look, I already have a number in the denominator, right? All of these can be put over 1. So what is left in my numerator will be 16a to the 10th. I'll erase that. So 16a to the 10th over 9 is in my denominator, but I'm moving b to the negative 2nd downstairs and making it b squared. So there's my final answer. So that was a pretty intimidating problem, but if you take it base by base, take your time, think distribute, it's pretty manageable. All right, so these are 7-4 notes. Thanks for watching.